Determine whether the sequence is geometric. If so, find the common rate. 3, 6, 12, 24. To find the ratio, divide 6 by 3, 12 by 6, and 24 by 12. Simplify 6 divided by 3. You find that 6 divided by 3 is equal to 2. Simplify 12 divided by 6. You find that 12 divided by 6 is equal to 2. Simplify 24 divided by 12. You find that 24 divided by 12 is equal to 2. Because the ratios are the same, the sequence is geometric. The common rate is 2. Determine whether the sequence is geometric. If so, find the common rate. 1, pi, pi squared, pi cubed. To find the rate, divide pi by 1, pi squared by pi, and pi cubed by pi squared. Simplify pi divided by 1. You find that pi divided by 1 is equal to pi. Simplify pi squared divided by pi. You find that pi squared divided by pi is equal to pi. Simplify pi cubed divided by pi squared. You find that pi cubed divided by pi squared is equal to pi. Because the rates are the same, the sequence is geometric. The common rate is pi. Determine whether the sequence is geometric. If so, find the common rate. 10, 15, 20, 25. To find the rate, divide 15 by 10, 20 by 15, and 25 by 20. Simplify 15 divided by 10. You find that 15 divided by 10 is equal to 3 halves. Simplify 20 divided by 15. You find that 20 divided by 15 is equal to 4 thirds. Simplify 25 divided by 20. You find that 25 divided by 20 is equal to 5 fourths. Because the rates are not the same, the sequence is not geometric. Determine whether the sequence is geometric. If so, find the common rate. 64, 32, 16, 8. To find the rate, divide 32 by 64, 16 by 32, and 8 by 16. Simplify 32 divided by 64. You find that 32 divided by 64 is 1 half. Simplify 16 divided by 32. You find that 16 divided by 32 is 1 half. Simplify 8 divided by 16. You find that 8 divided by 16 is 1 half. Because the rates are the same, the sequence is geometric, and the common rate is 1 half. Determine whether the sequence is geometric. If so, find the common rate. A sub n is equal to 4 times the quantity negative 1 half to the n. Divide a sub n plus 1 by a sub n. Simplify 4 times negative 1 half to the n plus 1 divided by 4 times negative 1 half to the n. You find that a sub n plus 1 divided by a sub n is equal to negative 1 half. The sequence is geometric and the common rate is negative 1 half. Find a formula for the nth term of the geometric sequence. Then find a sub 7. A sub 1 is equal to 1 and r is equal to 2. Use the formula a sub n is equal to a sub 1 times r to the n minus 1. Substitute 1 in for a sub 1 and 2 in for r. Simplify 1 times 2 to the n minus 1. You find the formula to be a sub n is equal to 2 to the n minus 1. Substitute 7 in for n. Simplify 7 minus 1. Simplify 2 to the 6th. You find that a sub 7 is equal to 64. Find a formula for the nth term of the geometric sequence. Then find a sub 7. A sub 1 is equal to 9, and r is equal to 2/3. Use the formula a sub n is equal to a sub 1 times r to the n minus 1. Substitute 9 in for a sub 1 and 2/3 in for r. You find the formula to be a sub n is equal to 9 times 2/3 to the n minus 1. Substitute 7 in for n. Simplify 7 minus 1. Simplify 2/3 to the 6th. Simplify 9 times 64 divided by 729. You find that a sub 7 is equal to 64/81. Find a formula for the nth term of the geometric sequence. Then find a sub 7. A sub 1 is equal to 2, and a sub 2 is equal to 4. To find the ratio, divide 4 by 2. Simplify 4 divided by 2. You find that r is equal to 2. Use the formula a sub n is equal to a sub 1 times r to the n minus 1. Substitute 2 in for a sub 1 and 2 in for r. You find the formula to be a sub n is equal to 2 times 2 to the n minus 1. Substitute 7 in for n. Simplify 7 minus 1. Simplify 2 to the 6th. Simplify 2 times 64. You find that a sub 7 is equal to 128.
Find a formula for the nth term of the geometric sequence. Then find a sub 7. A sub 1 equals 8 and a sub 2 equals 2. To find the rate, divide 2 by 8. Simplify 2 divided by 8. You find that r equals 1/4. Use the formula for the nth term of a geometric sequence. A sub n equals a sub 1 times r to the n minus 1 power. Substitute 8 in for a sub 1 and 1/4 in for r. You find that the formula for the nth term of this geometric sequence is a sub n equals 8 times 1/4 to the n minus 1 power. Now, to find a sub 7, substitute 7 in for n. Simplify 7 minus 1. Simplify 1/4 to the 6th power. Simplify 8 times 1 divided by 4096. You find that a sub 7 equals 1 divided by 512.
Find the nth partial sum of the geometric sequence. Round to the nearest hundredth if necessary. 4, 12, 36, 108. N is equal to 8. To find the ratio, divide 12 by 4, 36 by 12, and 108 by 36. Simplify the fractions. You find the rate to be 3. Use the formula a sub n is equal to a sub 1 times r to the n minus 1. Substitute 4 in for a sub 1 and 3 in for r. Use the formula for the nth partial sum of a geometric sequence. Substitute 8 in for n. Substitute 4 in for a sub 1 and 3 in for r. Simplify 3 to the 8th. Simplify 6,561 minus 1 and 3 minus 1. Simplify 6,560 divided by 2. Simplify 4 times 3,280. you find that the eighth partial sum of the geometric sequence is 13,120. Find the nth partial sum of the geometric sequence. Round to the nearest hundredth if necessary. 1, negative 3, 9, negative 27, 81. N is equal to 10. To find the ratio, divide negative 3 by 1, 9 by negative 3, negative 27 by 9, and 81 by negative 27. Simplify the fractions. You find that r is equal to negative 3. Use the formula a sub n is equal to a sub 1 times r to the n minus 1. Substitute 1 in for a sub 1 and negative 3 in for r. Simplify 1 times negative 3 to the n minus 1. You find that a sub n is equal to negative 3 times n minus 1. Use the formula for the nth partial sum of a geometric sequence. Substitute 10 in for n. Substitute 1 in for a sub 1 and negative 3 in for r. Simplify negative 3 to the 10th. Simplify 59,049 minus 1 and negative 3 minus 1. Divide 59,048 by negative 4. You find that the 10th partial sum of the geometric sequence is negative 14,762. Find the nth partial sum of the geometric sequence. Round to the nearest hundredth if necessary. 8, 4, 2, 1/2, and n equals 15. To find the ratio, divide 4 by 8, 2 by 4, 1 by 2, and 1/2 by 1. Simplify the fractions. You find that the rate is 1/2. Use the formula a sub n is equal to a sub 1 times r to the n minus 1. Substitute 8 in for a sub 1 and 1/2 in for r. Use the formula for the nth partial sum of the geometric sequence. Substitute 15 in for n. Substitute 8 in for a sub 1 and 1/2 in for r. Simplify 1/2 to the 15th. Simplify 1 divided by 32,768 minus 1 and 1/2 minus 1. Simplify negative 32,767 divided by 32,768 divided by negative 1/2. Simplify 8 times 65,534 divided by 32,768. Use a calculator to simplify 524,272 divided by 32,768. Round your answer to 2 decimal places. The 15th partial sum of the sequence 8, 4, 2, 1, 1/2 is 16. Find the nth partial sum of the geometric sequence. Round to the nearest hundredth if necessary. A sub n is equal to 3/4 to the n, and n is equal to 6. You find that a sub 1 is equal to 3/4 and r is equal to 3/4. Use the formula for the nth partial sum of a geometric sequence. Substitute 6 in for n. Substitute 3/4 in for a sub 1 and 3/4 in for r. Simplify 3/4 to the 6th. Simplify 729 divided by 4,096 minus 1 and 3/4 minus 1. Simplify negative 3,367 divided by 4,096 divided by negative 1/4. Use a calculator to simplify 3/4 times 3,367 divided by 1,024. Round your answer to 2 decimal places. The 6th partial sum of the geometric sequence is 2 and 47 hundredths. Find the partial sum. Round to the nearest hundredth if necessary. The sum from I equals 1 to I equals 10 of 2 to the I minus 1. Use the formula for the nth partial sum of a geometric sequence. Substitute 10 in for n. You find that a sub 1 is equal to 1 and r is equal to 2. Substitute 1 in for a sub 1 and 2 in for r. Simplify 2 to the 10th. Simplify 1024 minus 1 and 2 minus 1. Simplify 1023 divided by 1. You find that the sum from I equals 1 to I equals 10 of 2 to the I minus 1 is 1023. Find the nth partial sum of the geometric sequence. Round to the nearest hundredth if necessary. The sum from I equals 1 to I equals 12 of 3 times 3 halves to the I minus 1. Use the formula for the nth partial sum of a geometric sequence. Substitute 12 in for n. You find that a sub 1 is equal to 3 and r is equal to 3 halves. Substitute 3 in for a sub 1 and 3 halves in for r. Simplify 3 halves to the 12th. Simplify 531,441 divided by 4,096 minus 1 and 3 halves minus 1. Simplify 527,345 divided by 4,096 divided by 1 half. Simplify 3 times 1,054,690 divided by 4,096. Simplify 3,164,070 divided by 4,096. Round your answer to 2 decimal places. The sum from I equals 1 to I equals 12 of 3 times 3 halves to the I minus 1 is approximately equal to 772 and 48 hundredths. Find the sum. The sum from n equals 1 to infinity of 8 times 3 fourths to the n minus 1. Use the formula for the infinite geometric sum. You find that a sub 1 is equal to 8 and r is equal to 3 fourths. Substitute 8 in for a sub 1 and 3 fourths in for r. Simplify 1 minus 3 fourths. Simplify 8 divided by 1 fourth. You find that the sum from n equals 1 to infinity of 8 times 3 fourths to the n minus 1 is 32. Find the sum. The sum from n equals 0 to infinity of 2 times 2 thirds to the n. Use the formula for the infinite geometric sum. You find that a sub 1 is equal to 2 and r is equal to 2 thirds. Substitute 2 in for a sub 1 and 2 thirds in for r. Simplify 1 minus 2 thirds. Simplify 2 divided by 1 third. You find that the sum from n equals 0 to infinity of 2 times 2 thirds to the n is 6. Find the sum. The sum from n equals 0 to infinity of negative 3 sevenths to the n. Use the formula for infinite geometric sums. You find that a sub 1 is equal to 1 and r is equal to negative 3 sevenths. Substitute 1 in for a sub 1 and negative 3 sevenths in for r. Simplify 1 plus 3 sevenths. Simplify 1 divided by 10 divided by 7. You find the sum from n equals 0 to infinity of negative 3 sevenths to the n is 7 tenths. Find the sum. The sum from n equals 1 to infinity of 1 half to the n minus 1. Use the formula for infinite geometric sums. You find that a sub 1 is equal to 1 and r is equal to 1 half. Substitute 1 in for a sub 1 and 1/2 in for r. Simplify 1 minus 1/2. Simplify 1 divided by 1/2. You find the sum from n equals 1 to infinity of 1/2 to the n minus 1 is 2. Find the sum. The sum from n equals 1 to infinity of negative 1/2 to the n minus 1. Use the formula for infinite geometric sums. You find that a sub 1 is equal to 1 and r is equal to negative 1/2. Substitute 1 in for a sub 1 and negative 1/2 in for r. Simplify 1 plus 1/2. Simplify 1 divided by 3/2. You find the sum from n equals 1 to infinity of negative 1/2 to the n minus 1 is 2/3. Find the sum. The sum from n equals 0 to infinity of 1/10 to the n. Use the formula for infinite geometric sums. You find that a sub 1 is equal to 1 and r is equal to 1/10. Substitute 1 in for a sub 1 and 1/10 in for r. Simplify 1 minus 1/10. Simplify 1 divided by 9/10. You find the sum from n equals 0 to infinity of 1/10 to the n is 10/9. You accept the job as an archaeologist that pays a salary of $30,000 the first year. During the next 39 years, you receive a 5% raise each year. What is your total salary over the 40-year period? Set 30,000 equal to a sub 1, and 5% plus 1 equal to r. Add 1 because you are getting 100%, but you are adding 5% each year. You find that r is equal to 1 and 5/100ths. Use the formula for the nth partial sum of a geometric sequence. Substitute 40 in for n. Substitute 30,000 in for a sub 1 and 1 and 5/100ths in for r. Simplify 1 and 5/100ths to the 40th. Simplify 7 and 399 10,000ths minus 1 and 1 and 5/100ths minus 1. Multiply 30,000 by 6 and 399 10,000ths. Simplify 181,199 and 6,613 10,000ths divided by 5/100ths. Round your answer to 2 decimal places. Your total salary over the 40-year period will be $3,623,993.23. You work at a company that pays 1 cent for the first day, 2 cents for the second day, 4 cents for the third day, and so on. The daily wage keeps doubling. What is your total income for working A, 29 days, and B, 30 days? Set 1 cent equal to a sub 1, 2 cents equal to a sub 2, and 4 cents equal to a sub 3. To find the rate, divide 2 cents by 1 cent and 4 cents by 2 cents. Simplify the fractions. You find the rate is equal to 2. Part A. Use the formula for the nth partial sum of a geometric sequence. Substitute 29 in for n. Substitute 1/100th in for a sub 1 and 2 in for r. Simplify 2 to the 29th. Simplify 536,870,912 minus 1 and 2 minus 1. Simplify 1/100th times 536,870,911. You find that the sum is equal to 5,368,709 and 11/100ths. Part B. Use the formula for the nth partial sum of a geometric sequence. Substitute 30 in for n. Substitute 1/100th in for a sub 1 and 2 in for r. Simplify 2 to the 30th. Simplify 1,073,741,824 minus 1 and 2 minus 1. Simplify 1/100th times 1,073,741,823. You find that the sum is equal to 10,737,418 and 23 hundredths. Your total income for 29 days is $5,368,709.11, and 30 days is $10,737,418.23. Find the balance A in an increasing annuity in which a principal of P dollars is invested each month for T years compounded monthly at rate R. P is equal to $50, T is equal to 10 years, and R is equal to 9%. Use the formula A is equal to P times the quantity 1 plus R divided by N to the NT, where N is months per year. Substitute 50 in for P, 10 in for T, 9/100ths in for R, and 12 in for N. Simplify 9/100ths divided by 12, and 12 times 10. Simplify 1 plus 75 10,000ths. You find that A sub 120 is equal to 50 times 1 and 75 10,000ths to the 120th. Substitute 1 in for NT. Simplify 9/100ths divided by 12. Simplify 1 plus 75 10,000ths. You find that A sub 1 is equal to 50 times 1 and 75 10,000ths. Use the formula for the nth partial sum of a geometric sequence. Simplify 50 times 1 and 75 10,000ths, and simplify 1 and 75 10,000ths to the 120th. Simplify 2 and 4,513 10,000ths minus 1, and 1 and 75 10,000ths minus 1. Simplify 1 and 4,513 10,000ths divided by 75 10,000ths. Simplify 50 and 375 thousandths times 193 and 5,142 10,000ths. Round your answer to 2 decimal places. You find the balance to be $9,749.28. Find the balance A in an increasing annuity in which a principal of P dollars is invested each month for T years compounded monthly at rate R. P is equal to $30, T is equal to 40 years, and R is equal to 8%. Use the equation A is equal to P times the quantity 1 plus R divided by N raised to the NT, where N is the amount of months per year. Substitute 30 in for P, 40 in for T, 8/100ths in for R, and 12 in for N. Simplify 8/100ths divided by 12, and 12 times 40. Simplify 1 plus 66 10,000ths. You find that A sub 480 is equal to 30 times 1 and 66 10,000ths to the 480th. Substitute 1 in for NT. Simplify 8/100ths divided by 12. Simplify 1 plus 66 10,000ths. You find that A sub 1 is equal to 30 times 1 and 66 10,000ths. Use the formula for the nth partial sum of a geometric sequence. Simplify 30 times 1 and 66 10,000ths, and 1 and 66 10,000ths to the 480th. Simplify 24 and 2,733 10,000ths minus 1, and 1 and 66 10,000ths minus 1. Simplify 23 and 2,733 ten-thousandths divided by 66 ten-thousandths. Simplify 30 and 2/10 times 3,491 and 78 ten-thousandths. Round your answer to 2 decimal places. You find the balance to be $105,428.44. Find the balance A in an increasing annuity in which a principal of P dollars is invested each month for T years, compounded monthly at rate R. P is equal to $100, T is equal to 30 years, and R is equal to 6%. Use the formula A is equal to P times the quantity 1 plus R divided by N to the NT, where N is the amount of months per year. Substitute 100 in for P, 30 in for T, 6/100ths in for R, and 12 in for N. Simplify 6/100ths divided by 12 and 12 times 30. Simplify 1 plus 5/1000ths. You find that A sub 360 is equal to 100 times 1 and 5/1000ths to the 360. Substitute 1 in for NT. Simplify 6/100ths divided by 12. Simplify 1 plus 5/1000ths. You find that A sub 1 is equal to 100 times 1 and 5/1000ths. Use the formula for the nth partial sum of a geometric sequence. Simplify 100 times 1 and 5/1000ths, and simplify 1 and 5/1000ths to the 360. Simplify 6 and 225 ten-thousandths minus 1, and 1 and 5/1000ths minus 1. Simplify 5 and 22 ten-thousandths divided by 5/1000ths. Simplify 100 and 5/10ths times 1004 and 5,150 ten-thousandths. Round your answer to 2 decimal places. You find the balance to be $100,953.76.
Evaluate the binomial coefficient NCR for 6C4. The binomial coefficient for NCR is n factorial divided by n minus r factorial times r factorial. So the binomial coefficient of 6C4 is 6 factorial divided by 6 minus 4 factorial times 4 factorial. After writing out the factorials, you see there's a 4, a 3, a 2, and a 1 in both the numerator and denominator, so they cancel out. You're left with 6 times 5 divided by 2 times 1, which is equal to 15. So the binomial coefficient 6C4 is equal to 15. Evaluate the binomial coefficient NCR, 10C5. The equation for a binomial coefficient is NCR equals n factorial divided by n minus r factorial times r factorial. Substitute 10 into this equation for n and 5 into this equation for r. 10 factorial divided by 10 minus 5 factorial times 5 factorial. After expanding the factorials, you see there is a 5, 4, 3, 2, and 1 in both the numerator and denominator, so they cancel out. You are left with 10 times 9 times 8 times 7 divided by 5 times 4 times 3 times 2 times 1, which is equal to 252. So 10C5 is equal to 252. Evaluate the binomial coefficient NCR, 12C12. The equation for a binomial coefficient is NCR equals n factorial divided by n minus r factorial times r factorial. Substitute 12 into this equation for n and 12 into this equation for r. You get 12 factorial divided by 12 minus 12 factorial times 12 factorial. The 12 factorials cancel out. you're left with 1 divided by 0 factorial. 0 factorial is equal to 1. So 12c12 is equal to 1. Evaluate the binomial coefficient NCR, 20c6. The binomial coefficient NCR is equal to n factorial divided by n minus r factorial times r factorial. Substitute 20 into this equation for n and 6 into this equation for r. You are left with 20 factorial divided by 20 minus 6 factorial times 6 factorial. 20 factorial can be written as 20 times 19 times 18 times 17 times 16 times 15 times 14 factorial. 20 minus 6 factorial is 14 factorial, and 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. The 14 factorials cancel out. This simplifies to 38,760. So 20c6 is equal to 38,760. Evaluate the binomial coefficient NCR. 20c14. The binomial coefficient of NCR is equal to n factorial divided by n minus r factorial times r factorial. Substitute 20 into this equation for n and 14 into this equation for r. 20 factorial divided by 20 minus 14 factorial times 14 factorial. 20 factorial is 20 times 19 times 18 times 17 times 16 times 15 times 14 factorial. 20 minus 14 factorial is 6 factorial, which is equal to 6 times 5 times 4 times 3 times 2 times 1. There is a 14 factorial in both the numerator and denominator, so they cancel out. This simplifies to 38,760. So 20c14 is equal to 38,760. Find the 8th row of Pascal's triangle using the diagram below. Starting from the left, the first number is 1, because the ends of the triangle are always 1. To find the second number, add the two numbers above it. The two numbers above it are 7 and 1, and 7 plus 1 is 8. Do the same thing for the next. The two numbers are 7 and 21, 7 plus 21 is 28. The next one is 21 and 35. 21 plus 35 is 56. In the middle, there's 35 plus 35, which is equal to 70. The right half of the triangle mirrors the left half. So after 70, you have 56, then 28, then 8, then 1. The 8th row of Pascal's triangle is 1, 8, 28, 56, 70, 56, 28, 8, 1. Use Pascal's triangle to evaluate NCR for 6C2. Start by drawing Pascal's triangle. 6C2 is going to be in the 6th row and is going to be the second entry. Start by finding the 6th row. Note that row 1 is second from the top. So row 6 is 5 below that row. Now find the second entry in this row. You do not count the 1s at the ends, so the first entry is 6, and the second entry is 15. This means 6C2 is equal to 15. Use Pascal's triangle to evaluate NCR for 7C3. Start by drawing Pascal's triangle. 7C3 is the third entry in the 7th row. Start by finding the 7th row. Note that row 1 is second from the top, so row 7 is 6 rows below this. Now find the third entry in this row. Note that the 1s on the ends don't count, so 7 is the first entry, 21 is the second entry, and 35 is the third entry. So 7C3 is equal to 35. Use Pascal's triangle to evaluate NCR for 8C4. Start by drawing Pascal's triangle. 8C4 is the fourth entry in the 8th row. Start by finding the 8th row. Note that row 1 is second from the top. Row 8 is 7 rows below this. Now find the fourth entry. The 1 on the end does not count, so 8 is the first entry, 28 is the second entry, 56 is the third entry, and 70 is the fourth entry. So 8C4 is equal to 70. Use Pascal's triangle to evaluate NCR for 5C3. Start by drawing Pascal's triangle. 5C3 is the third entry in the 5th row. Start by finding the 5th row. Note that row 1 is second from the top. The 5th row is 4 rows below this. Now find the third entry in this row. The 1 at the end does not count, so 5 is the first entry, 10 is the second entry, and the second 10 is the third entry. So 5C3 is equal to 10. Use Pascal's triangle to evaluate NCR for 7C4. Start by drawing Pascal's triangle. 7C4 is the fourth entry in the 7th row. Start by finding the 7th row. Note that row 1 is second from the top. Row 7 is 6 rows below this. Now find the fourth entry in this row. The 1 on the end is a 0th entry, 7 is the first, 21 is the second, 35 is the third, and the second 35 is the fourth entry. So 7C4 is equal to 35. Use Pascal's triangle to expand the expression t plus 5 cubed. Start by finding the third row in Pascal's triangle, because the quantity is cubed. The third row is 1, 3, 3, 1. Use these to expand the expression. The first term is 1 times t cubed times 5 to the 0th power plus 3 times t squared times 5 to the first power plus 3 times t to the first power times 5 squared plus 1 times t to the 0th power times 5 cubed. The power that t is raised to goes from 3 to 2 to 1 to 0. The power that 5 is raised to goes from 0 to 1 to 2 to 3. This simplifies to t cubed plus 15t squared plus 75t plus 125. Use Pascal's triangle to expand the expression, the quantity m minus n to the 5th power. Start by finding the 5th row in Pascal's triangle. The 5th row is 1, 5, 10, 10, 5, 1. Use these values to expand the expression. The first term is 1, the first number in the row, times m to the 5th power times negative n to the 0th power. The second term is 5, the second number in the row, times m to the 4th power times negative n to the first power. The pattern continues with the power of m decreasing and the power of negative n increasing. The simplified expression is m to the 5th power minus 5m to the 4th power times n plus 10m cubed times n squared minus 10m squared times n cubed plus 5mn to the 4th power minus n to the 5th power. Use the binomial theorem to expand the expression, the quantity x plus 3 to the 6th power. Start by finding the 6th row of Pascal's triangle. It's 1, 6, 15, 20, 15, 6, 1. So the expansion is as follows. 1 times x to the 6th power times 3 to the 0th power plus 6 times x to the 5th power times 3 to the 1st power plus 15 times x to the 4th power times 3 squared plus 20 times x to the third power times 3 to the third power, plus 15 times x squared times 3 to the fourth power, plus 6 times x to the first power times 3 to the fifth power, plus 1 times x to the 0th power times 3 to the sixth power. The power the x is raised to decreases by 1 each time, and the power the 3 is raised to increases by 1 each time. This simplifies to x to the 6th power plus 18x to the 5th power, plus 135x to the 4th power, plus 540x to the 3rd power, plus 1215x squared, plus 1458x plus 729. Use the binomial theorem to expand the expression, the quantity u minus v to the third power. Start by finding the third row of Pascal's triangle. The third row is 1, 3, 3, 1. So the expansion is as follows. 1 times u cubed times negative v to the 0th power, plus 3 times u squared times negative v to the first power, plus 3 times u to the first power times negative v squared, plus 1 times u to the 0th power times negative v cubed. The power the u is raised to decreases by 1 each term, and the power the negative v is raised to increases by 1 each term. The simplified expression is u cubed minus 3u squared times v plus 3uv squared minus v cubed. Use the binomial theorem to expand the expression, the quantity 3a minus 1 to the 5th power. Start by finding the 5th row of Pascal's triangle because the quantity is raised to the 5th power. The 5th row is 1, 5, 10, 10, 5, 1. The expansion is as follows. 1 times 3a to the 5th power times negative 1 to the 0th power, plus 5 times 3a to the 4th power times negative 1 to the 1st power, plus 10 times 3a cubed times negative 1 squared, plus 10 times 3a squared times negative 1 cubed, plus 5 times 3a to the 1st power times negative 1 to the 4th power, plus 1 times 3a to the 0th power times negative 1 to the 5th power. The power the 3a is raised to decreases by 1 each time, and the power that negative 1 is raised to increases by 1 each time. The simplified expression is 243a to the 5th power minus 405a to the 4th power plus 270a cubed minus 90a squared plus 15a minus 1. Use the binomial theorem to expand the expression, the quantity 2y plus c to the 6th power. Start by finding the 6th row of Pascal's triangle. The 6th row is 1, 6, 15, 20, 15, 6, 1. The expansion is as follows. 1 times 2y to the 6th power times z to the 0th power, plus 6 times 2y to the 5th power times z to the 1st power, plus 15 times 2y to the 4th power times z squared, plus 20 times 2y to the 3rd power times z to the 3rd power, plus 15 times 2y squared times z to the 4th power, plus 6 times 2y to the 1st power times z to the 5th power, plus 1 times 2y to the 0th power times z to the 6th power. The power the 2y is raised to decreases by 1 each term, and the power that z is raised to increases by 1 each term. The simplified expression is 64y to the 6th power plus 192y to the 5th power times z, plus 240y to the 4th power times z squared, plus 160y to the 3rd power times z to the 3rd power, plus 60y squared times z to the 4th power, plus 12y times z to the 5th power, plus z to the 6th power. Use the binomial theorem to expand the expression, the quantity x squared plus 2 to the 4th power. Start by finding the 4th row of Pascal's triangle. The 4th row is 1, 4, 6, 4, 1. The expansion is as follows. 1 times x squared to the 4th power times 2 to the 0th power plus 4 times x squared to the third power times 2 to the first power, plus 6 times x squared squared times 2 squared, plus 4 times x squared to the first power times 2 to the third power, plus 1 times x squared to the 0th power times 2 to the 4th power. The power the x squared is raised to decreases by 1 each term, and the power the 1 is raised to increases by 1 each term. The simplified expression is x to the 8th power plus 8x to the 6th power plus 24x to the 4th power plus 32x squared plus 16. Use the binomial theorem to expand the expression, the quantity 3a plus 2b to the 4th power. Start by finding the 4th row in Pascal's triangle. The 4th row is 1, 4, 6, 4, 1. The expansion is as follows. 1 times 3a to the 4th power times 2b to the 0th power plus 4 times 3a cubed times 2b to the 1st power plus 6 times 3a squared times 2b squared plus 4 times 3a to the 1st power times 2b cubed plus 1 times 3a to the 0th power times 2b to the 4th power. Note that the power the 3a is raised to decreases by 1 each term, and the power the 2b is raised to increases by 1 each term. The simplified expression is 81a to the 4th power plus 216a cubed b plus 216a squared b squared plus 96ab cubed plus 16b to the 4th power. Use the binomial theorem to expand the expression, the quantity x plus 2 divided by y raised to the 4th power. Start by finding the 4th row of Pascal's triangle. The 4th row is 1, 4, 6, 4, 1. The expansion is as follows. 1 times x to the 4th power times 2 divided by y to the 0th power plus 4 times x cubed times 2 divided by y to the 1st power plus 6 times x squared times 2 divided by y squared plus 4 times x to the 1st power times 2 divided by y cubed plus 1 times x to the 0th power times 2 divided by y to the 4th power. The power the x is raised to decreases by 1 each term, and the power the 2 divided by y is raised to increases by 1 each term. The simplified expression is x to the 4th power plus 8x cubed divided by y plus 24x squared divided by y squared plus 32x divided by y cubed plus 16 divided by y raised to the 4th power. Use the binomial theorem to expand the expression, the quantity 2x squared minus y raised to the 5th power. Start by finding the 5th row of Pascal's triangle. The 5th row is 1, 5, 10, 10, 5, 1. So the expansion is as follows. 1 times 2x squared to the 5th power times negative y to the 0th power, plus 5 times 2x squared to the 4th power times negative y to the 1st power, plus 10 times 2x squared cubed times negative y squared, plus 10 times 2x squared squared times negative y cubed, plus 5 times 2x squared to the 1st power times negative y to the 4th power, plus 1 times 2x squared to the 0th power times negative y to the 5th power. The power the 2x squared is raised to decreases by 1 each time, and the power the negative y is raised to increases by 1 each time. This simplifies to 32x to the 10th power minus 80x to the 8th power times y, plus 80x to the 6th power times y squared, minus 40x to the 4th power times y cubed, plus 10x squared times y to the 4th power, minus y to the 5th power. Find the specified term in the expansion of the binomial, the quantity x plus y raised to the 10th power. Find the 4th term. The r plus 1th term in a binomial raised to the nth power is NCR times x raised to the n minus r power times y raised to the r power. You are trying to find the fourth term, so r plus 1 is equal to 4, meaning r is equal to 3. And the binomial is raised to the 10th power, so n is equal to 10. The fourth term is 10c3 times x raised to the 10 minus third power times y raised to the third power. 10c3 is equal to 10 factorial divided by 7 factorial times 3 factorial, which equals 120. The fourth term in the expansion of this binomial is 120 times x raised to the 7th power times y raised to the 3rd power. Find the specified term in the expansion of the binomial, the quantity a plus 6b raised to the 9th power. Find the fifth term. The r plus 1th term in a binomial raised to the nth power is ncr times x raised to the n minus r power times y raised to the r power. We are looking for the fifth term, so r plus 1 is equal to 5, meaning r is equal to 4. The binomial is raised to the 9th power, so n equals 9. The first term in the binomial is a, so we will call x a, and the second term in the binomial is 6b, so we will call y 6b. The fifth term is 9c4 times a raised to the 9 minus 4th power times 6b raised to the 4th power. 9c4 is equal to 9 factorial divided by 5 factorial times 4 factorial, which is equal to 126. The fifth term is 126 times a to the 5th power times 1296b to the 4th power. This simplifies to 163,296 a to the 5th power b to the 4th power. Find the specified term in the expansion of the binomial. The quantity 4x plus 3y raised to the 9th power. Find the 8th term. The r plus 1th term in a binomial raised to the nth power is ncr times x raised to the n minus r times y raised to the r. You are trying to find the 8th term, so r plus 1 is equal to 8, meaning r is equal to 7. The binomial is raised to the 9th power, so n is equal to 9. The first term in the binomial is 4x, so we will call x 4x. And the second term in the binomial is 3y, so y will be 3y. The 8th term in the expansion of this binomial will be 9c7 times 4x squared times 3y raised to the 7th power. 9c7 is equal to 9 factorial divided by 2 factorial times 7 factorial, which is equal to 36. The 8th term is 36 times 16x squared times 2,187 y raised to the 7th power. The 8th term in the expansion of this binomial is 1,259,712 x squared y raised to the 7th power. Find the coefficient of the given term in the expansion of the binomial. The expression is the quantity x plus 1 raised to the 10th power, and the term is x raised to the 7th power. The r plus 1th term in a binomial raised to the nth power is ncr x raised to the n minus r times y raised to the r. The binomial is raised to the 10th power, so n is equal to 10. The term in question is x raised to the 7th power, so n minus r has to be equal to 7. Using that n is equal to 10 and n minus r is equal to 7, you can find that r is equal to 3. The first term in the binomial is x, so we will call x x, and the second term in the binomial is 1, so y is 1. The x raised to the 7th term is 10c3 x raised to the 7th times 1 raised to the 3rd power. The coefficient of this term is 1 raised to the 3rd power times 10c3, which is equal to 10 factorial divided by 7 factorial times 3 factorial, which equals 120. The coefficient of x raised to the 7th is 120. Find the coefficient of the given term in the expansion of the binomial. The expression is the quantity x plus 1 raised to the 12th power, and the term is x raised to the 9th power. The r plus 1th term in a binomial raised to the nth power is NCR times x raised to the n minus r power times y raised to the r power. The expression is raised to the 12th power, so n is equal to 12. The term is x to the 9th power, so n minus r is 9. Given that n is equal to 12 and n minus r is equal to 9, you can find that r is equal to 3. The first term in the binomial is x, so we will call x x. The second term in the binomial is 3, so we will call y 3. The x to the 9th term is 12c3 x raised to the 9th power times 3 raised to the 3rd power. The coefficient of this term is 3 raised to the 3rd power times 12c3, which is equal to 27 times 12 factorial divided by 9 factorial times 3 factorial, which equals 5,940. So the coefficient of x raised to the 9th power is 5,940.